So we have already solved systems of equations by graphing. That was the first method that we used. That's what we took a quiz on. The second thing that we have is solving systems by substitution. That's usually out of the three considered the most challenging. However, it is the one that you will see used a lot when you go up to Algebra 2, when you use other types of problems, not just linear problems. When you plug it into quadratics and other things, that will be one of the most common ways that you solve systems with. And then there is elimination, which I would consider the easiest. Most people do. And on your test, you'll have like a set of problems you have to do by substitution, a set of problems you have to do by graphing, and a set you have to do by elimination. And then the other problems, you will get to choose whichever method you want to do. So this is going to be the third of those methods. Let's get started in showing you how to do this. This is going to be done by eliminating one of the variables. It's going to be like old school arithmetic, guys. When you had something like 25 added to 13, you line them up so that the ones lined up, the tens lined up. You added these, the like columns together. The 5 and the 3 went together and you got 8, and then the 2 and the 1 together to get 3. That's the kind of arithmetic we're going to be doing, but we're going to be doing it with systems of equations. To do that, they need to be in standard form-ish. We don't have to worry about the negatives in front and all that, but we do need to have the variables over here on the left in order, x and then y, and the numbers over there on the right. If they're not, you have to rearrange them. These are in standard form-ish. Like I said, we're not going to worry about the negative. What we're going to do is put a line underneath here, and we're going to try to see if any of our variables cancel out. If we combine our like terms going down, are any of our variables going to cancel out? Yes. So we've already got elimination, guys. We're going to eliminate the x, and we're going to combine the y's. When I combine 4y and negative 6y, that's going to give me negative 2y. Then when I combine the 12 and the 18, it's going to give me a total of 30. We're going to divide both sides by negative 2, and y is going to equal negative 15. That is the y from your ordered pair, so it goes in the second spot in your ordered pair. And what's unique about this is because you don't have a box to plug it into, you can plug it into either one of your equations. Doesn't matter. I'll plug it into the first one this time and the second one next time. Here we go. Negative 3x plus 4 times negative 15 equals 12. I'm plugging it into the y in this first equation. That's going to make it negative 3x. Guys, a positive 4 times a negative 15 is going to give you a negative 60. Good. Negative 60. You're good. I'd rather you try. Then add 60. Add 60. It's going to give you negative 3x is equal to 72. We're going to divide both sides by negative 3. First of all, guys, a positive divided by a negative is a negative. And what's 72 divided by 3?
Negative 24.
Perfect. So negative 24 would be the x part of your ordered pair. And that would, guys, this is the solution to this system of equations. When it asks for the solution, this is the solution. This is the point that would make both of these true or equal to each other on either side. Does anybody have any questions so far? Now, guys, they will not all start like that. They will not start where something cancels out immediately every single time. Sometimes you're going to have to multiply something and make it cancel out. Let's show you what we mean. If we put our line underneath here, does anything cancel out?
4.
No, they do not. 4 plus 4 is not 0.
Oh, is it always that?
It's always adding, guys. So does anything cancel out?
Nope.
Nope. What we need to do is change one of our equations so that one of the 4's is going to be negative. What could we multiply everything in the second equation by to make everything down here into a negative? Negative 1. When you do that, you're going to put a negative 1 outside the parentheses, and you're going to write the first. Guys, listen to me. Some people try to skip this step, and then it bites them in the behind because they don't know which equations are. Draw your line, copy the first equation down, don't change it. Then write the new one with the negative 1 being distributed to everything that's here. That would make the 4x into a negative 4x. That would make the negative 3y into a positive 3y. And that would make the positive 18 into a negative 18. Draw another line. Now does one of your variables cancel out? Which one? That would be the what? The x's. So that when you combine your y's, 2y plus 3y is going to be a total of 5y equal to, and what is 28 minus 18? 10. From there we divide both sides by 5, and y equals 2. Okay, guys, that's the first part of my ordered pair. It is the second number in my answer. It is going to be plugged back in. Which one did we plug it in last time? The first one? So I'm going to do the second one just to show. It doesn't matter. You'll get the same answer no matter which one you plug it into. But here we go. 4x minus 3 times 2 equals 18. Does everybody understand? I'm plugging in the second one, and I'm plugging in where the y is in the second one. That's where I'm plugging it into. Yep.
So if you change the equation and make it like a negative, you still when you plug it back, you plug it back into the.
You're always plugging back into the original ones. Actually, it doesn't make any difference. You get the same answer. It doesn't matter. It doesn't matter at all. It's not going to change it. You can plug it in any one you want to. Yep. It's not. It's elimination is very flexible, is what I'm trying to say. Okay. 4x. Oh, yeah.
So whenever the two x's have the same number, you always try to change one of them to a negative.
You need one positive and one negative of the same number, no matter whether it's the x's or the y's.
Okay.
It's got to be the same number, one of each. Good. Okay, guys, so when we multiply by 2, that's going to make it 4x minus 6 equals 18. We're going to add 6 to both sides. It's going to make it 4x is equal to 24.
Yes.
Divide both sides by 4, and x equals 6. There's your solution. That is the solution to this system of equations. Okay. Questions, concerns, anything that you have a question about so far? Feeling okay?
Mm-hmm.
Okay. Here we go. Let's try it again. Alright, for this one, does anything cancel out like they are?
No.
So you're going to have to multiply. Now, listen to how some people really struggle with this concept. So look at what I'm going to show you. Guys, can we multiply 2 by something and make it into 3? Not unless you're using fractions, and we're not getting into that. Can you multiply 3 by something and make it into 2? No. What number's really here?
1.
Can I multiply 1 by something and make it into 2? Yes. What could I multiply by?
2.
Okay, so I'm going to start with the idea that I'm going to multiply by 2. But if I multiply by 2, that's not going to cancel out. It's just going to be a 2 and a 2. So what kind of 2 do I need to multiply by?
Negative.
A negative 2. Because when I multiply by negative 2, this is what's going to happen. Negative 2 times 2x is going to be negative 4x. Negative 2 times y is going to be negative 2y. And negative 2 times 23 is negative 46. Right? From there, we copied it. Guys, listen to me. You've got to learn to do this. Don't try to short the work for this. Just copy the other one underneath it, draw your line. Every single one of these is going to have it set up like that, where it's two of them. You got to do it every time until you can start canceling something out. Can you cancel something out now?
Yes. Yes.
What?
The y.
The two y's. However you want to say it, the y's, the two y's, the y's with the twos in front. Okay, when I combine the x's, negative 4x and positive 3x is going to give you what? The opposite of x equals what? Negative 9. Okay. How are you going to get that x by itself? Hold on. This is Miss Riley? Hey. Yes. Yes. Thank you. Thank you for letting me know. I appreciate it. Bye. She was just letting me know she's down there. Perfect. Okay. So we divide both sides by negative 1, and x equals 9. Perfect. That's your x, so it goes in the x spot. It goes right there. Okay, we plug it back in. Guys, does it matter which one you plug it into? No, but the numbers in the first one are smaller, so I'm going to pick the first one. It doesn't matter. You get the same exact answer, but here we go. 2 times 9, I'm plugging in where the x is because it says x equals plus y equals 23. 2 times 9 is 18 plus y equals 23. We minus 18, minus 18. Y equals, what is 23 minus 18? 5. There you go. There's your solution. Okay. See some faces, kind of making questioning looks. Does anybody have any questions up till this point? I see some real confidence, but I also see a couple people that maybe they're not willing to ask yet. Anybody see anything they're having trouble with? Not yet? Okay. Got a couple more of these. Guys, if you hit something that you don't understand why I did something, you need to ask me a question about it. A couple people still working, guys. Let them get done. Okay. Anybody still writing? Wonderful. Here we go. Next one. Guys, looking at these two things, can you make 3 into 2 or 2 into 3? Nope. Can you make 5 into 10 or 10 into 5?
Yes.
Yes. We need to multiply the top to make the 5 into 10 by multiplying it by what?
It'd be negative 2, right?
That's, guys, what do you have to multiply 5 by to make it into 10? Just that part. 2. Do I need to multiply it by a negative? Yes, because guys, right now they're both negative, and one of them has to be what? Positive in order for them to cancel out. So we're going to multiply by negative 2 on the top. That's going to make it negative 6x. And then the negative 2 times 5 is going to make it positive 10y. And then a negative times the negative is going to make the last one a positive, and then 2 times 29 would make it 58. Is it 8? Perfect.
Yes.
Wonderful. We take the second one and we write it underneath it just like it is. Do not do anything to it. Just copy it so you can put your line. Does one of your variables now cancel out? Yes. Cancel it. Your y's go away. Your x's combine to give you negative 4x equals what?
16.
Yep. Divide both sides by negative 4, and x equals negative 4. To get the second part of that problem, you're going to plug it back into one of your equations. It makes no difference which one you plug it into. Since I've used the top one on the last one, I'm going to use the bottom one on this one. 2 times negative 4 minus 10y equals negative 42. That's going to be negative 8 minus 10y equals negative 42. I'm going to add 8. Don't panic when you get this answer. It's going to be negative 10y equals negative, guys, what's negative 42 plus 8? Negative, what is it?
34.
34. Then you're going to divide both sides by negative 10, which is going to make it y equals, guys, don't say it, but first of all, a negative divided by a negative is a positive. So first thing you're going to do is cancel out the negative sign. The second thing you're going to do is type this in on the calculator. Type in the 34. You did. I messaged you. You didn't see it? I messaged you on I put it in my drawer. One of my students brought it up to me. Who was it? Thank you. I think it was Gabby. There you go. You're welcome, sweetie. Thank you. Okay. So when you type this in on the calculator, you're going to first it won't let you type the double negatives in on the calculator, guys. It's not going to put the negative on the bottom of a fraction. So you're going to type it in as 34 fraction button 10 equals. Then you're going to type in there second fraction button equals. It's going to give you a fraction. What's on top?
17
over
5.
There you go. You will get some fractions. It's okay. They are not bad. I know you don't like them, but they're not bad. You're going to get some answers that are not perfect numbers. Okay. We have one last problem. And I did this one mainly because a lot of people struggle with this. And I'm hoping that when we talk through this, you'll understand why you have to do what you have to do. Anybody on this one before we do our last one? Okay, here we go. For this last one, guys, can you make 4 into 3?
No.
Can you make 3 into 4?
No.
Can you make 3 into 5?
No.
Can you make 5 into 3?
No.
So do you understand you're going to have to multiply both equations to be able to do this? You can't just multiply one of them and turn it into the other one. Now, if you already have a pair that are positive and negative, those would be the ones that I would try to multiply to cancel out, because then you don't have to multiply by a negative. I've already got a positive 3 and a negative 5 on my y's. What is a common number that 3 and 5 will go into?
15.
So what do I have to multiply 3 by to make it into 15?
5.
I'm going to have to multiply by 5. What do I have to multiply 5 by to make it into 15? 3. Questions on just that part? Guys, it's the idea of like looking for a least common denominator. I'm looking for the smallest number they'll both go into. Alright, it's called a least common multiple. We use it when we do least common denominators. Here we go. 5 times 4x is 20x. 5 times 3y is 15y. 5 times 8 is 40. You cannot forget to multiply times all three of them. 3 times 3x is 9x. 3 times negative 5 is going to be negative 15y. And 3 times negative 23 is going to be negative 69. What cancels out? When I combine my like terms and I combine the two x's, 20x plus 9x is going to give me 29x. When I do 40 minus 69, what's that going to be? Negative 29. So that when you divide both sides by 29, x equals negative 1. Now, pause for a minute, just so we know this. Guys, can you get special cases still on this? Yes. If the variables go away and you get something like 0 equals 7 and their sides are not equal, what is the answer? No solution. If you end up with something like 8 equals 8, or 0 equals 0, or negative 7 equals negative 7, what is the answer? Infinitely many solutions. Now, there are, I think, 3 of those on the homework assignment, so you are going to see some of these. I just didn't want to waste them because those are pretty straightforward. They're much faster. There's not a lot of work to those. No plugging back in. The first step usually takes care of it. But I just want to make sure you know you can still get those. Okay, let's finish this out. Plug it back into one of them. I'm going to do the top one because there's no negatives. I just like to do that. It's going to be 4 times negative 1 plus 3y equals 8. I'm plugging back in where the x is in this problem. If you plug in the second one, you still get the same answer.
But it's just a lot of work.
Yeah. It's more chance to mess up because you got more negative signs. Yep. It's not right or wrong. Negative 4 plus 3y equals 8. To get rid of the negative 4, we add 4. You get 3y equals 12. Divide both sides by 3, and y equals 4. That's your solution. Okay, guys. So, we're going to use this to get our 2 worksheets done. Let's go ahead and